Hello everybody and welcome to another tutorial. In this tutorial we are going to look at this nice death effect, as I would call it, and there are two effects. One is kind of like in the Matrix, where as you see it transforms the animated thing into cubes. The other one is it burns it down. And this tutorial, or this effect, is consists of two parts. One is a shader graph to kind of make the mesh disappear, and the other one is a VFX graph that creates either the fire or the pixels. They are in implementation, they are relatively similar to each other. But yeah, let's just jump into how these effects actually work. And we have our Walker prefab. These three things are just part of the object itself. This is where the joints are, which has this color, and that's the rest of the body, which has this color. Both of these I changed the material such that it uses our own shader, and then I added an empty object which has the visual effect. Right, jumping to the actual visual effect, there are two pieces of it. One is once the hit happens, it will burst a number of particles, and the other one is the one that keeps on spawning as long as it's not fully hidden. Okay, so to begin with, it's a constant spawn rate, right, with some parameterized number, and then our initialized particle. And by the way, this is somewhat similar to the last tutorial about burning anything. Yeah, there are some additions to that though. So the initialized particle is going to here you have to set some capacity based on the maximum number, approximation of the maximum number of particles that's going to be at one point. So you should make it as small as possible, because this takes a section of memory and it cannot be parameterized. Anyways, we start by positioning, and remember this, I think, I'm not sure if the latest has this open or not, but these things are enabled by going to project settings, and then you go to VFX, or not VFX, actually that was edit preferences, and then you go to visual effects and you enable the experimental operator blocks, which is going to show you this block. Right, this block sets the position of the particle based on a skinned mesh and its parameter, which is the the mesh, the animated mesh, right, the skinned mesh on the animated mesh. So you just plug it in. We want to put it based on the surface, and it's random. And then after that we want to add the position, and that's because we are simulating in local space, and so so that when we calculate the hit, we don't need to change that position. We can just give it a local position where the hit happened, and then here we can add the position of the source, right, which is the object emitting the particles. And so adding that to our local space simulation will make it move with the animated object. So we're just adding that. We are setting some random lifetime based on parameters also, and then this guy, the multiply lifetime, is what kills everything except for the intersection between a ball and the actual mesh. And to look at that, it's what I'm calling the ball edge calculation. So the actual calculation is this, right? It's the position of the particle itself, right? And this is the hit, this is the ball, which is going to be where we hit the object, and we are going to animate the size of the ball. So the position, the distance between the position of the ball and the current particle being calculated. So we get the distance, right? We add this stuff is just some noise, right? I'm gonna go into detail in a little bit, but the idea is we get the distance between the ball and the particle. We add some noise to it, and here we subtract the size of the ball from that value, and we get the absolute. We plug it into a step function, and the distance threshold is a parameter again, which defines how thick that edge of the ball should be, which is and you can ignore this multiplier. Yeah, you can plug it in directly to the lifetime. Yeah, so this is gonna kill all particles except the ones that are in the intersection between the ball and the mesh. Now this random or this noise thing, it's more of a squares all over the mesh. As you may have noticed, the mesh disappears in squares, and this might actually not add a lot of value, but I did it anyways because it's the same as what we have in the shader, which is gonna make the mesh disappear, right? We take some value, a float of the size, multiply it by the position of the particle, and then we get the floor, and to the floor we do a dot product with just some kind of random big value, right, for both x, y, and z, but this value has to be the same as what we put in the shader, right? And then we get the sign of that, so that we have a number between -1 and 1, and we multiply it by the noise power, and yeah, that's it. We add it to our calculation, as I mentioned. So that's how you kill all the particles that are not in that intersection. After that, we are setting the velocity of the particle to be some random. So on y we don't want to set anything, we just want to set on x and z to be something kind of random, right? So this is a parameter that we can change, and it's we are plugging it as the maximum and multiply it by minus and put it as the minimum for a random number per particle. And obviously we need a different seed for x and y, yeah, and just a vector 3 which is gonna set our velocity so that each cube kind of goes into a different position. In the update particle, we are just going to add gravity so that they fall down, and sadly the collision in URP is not it's quite limited, so you have to for example have either a plane or like a sphere or something like that. In HD you can have something like a depth field, which is much more like you can have a camera that renders from top view the depth of the kind of floor if the ground is not leveled, and use that probably as a collision. But in URP you cannot do that, so I'm just using a plane so that they kind of bounce on that plane, and you can see I added some friction and whatnot. And then we wanna put it into an output of a particle URP lit mesh. I didn't change anything of these. You can change whatever you want from these. And then we have a set color over life, which is also parameterized. It's just some green and then it becomes transparent, or I guess gray and then transparent, and set size over life, which is, you know, something big and then it gets smaller. Now for the burst, I have an event called onHit, which is connected to the start of the spawn, which means you have to send an event from a C# script to invoke the start of this spawn, right? Once you do that, it's gonna spawn a single burst of 5,000 particles, and your capacity should be the same as the count, because you don't need any more than that. Yeah, and then it's almost the same as what we have here, right? So you can see I'm connecting the same stuff here and there, except for the this multiply lifetime. It's going to be different because we want everything outside of the ball to die and anything inside of that ball to stay there, right? And so we're just going to use the value of the addition of our noise and the distance, and then add 1 to our distance threshold and use that as the value. After that, yeah, so this is basically going to kill everything outside of that ball. Yeah, and after that we are setting the velocity to be something we want that ball to like kinda explode. So what I'm doing is I am transforming the ball position from local space to this W means it's going to be transformed to world space, and then I am subtracting the current position of the particle from that, which is going to give me a vector from where the particle spawned, or the other way around actually, from the center of the ball towards where the particle spawned, right? And then I'm just multiplying some random value for each particle between 2 and 2.5, so that they don't all fly in the same force, you can say. Obviously you can make these parameterized, yeah. And then I am just adding that vector that we just talked about, as well as, or adding that to our random X and Z from here. Yeah, after that the same for all of these, right? These are exactly the same, and that's our effects. That's the VFX effect for the cubes, right? If we jump to the shader, we're gonna see that we have the same concept here. It's the size multiplied by the position in object space, getting the floor of that, doing a dot product with the same values for that vector 3, which is going to give you some squares like this, and then we multiply it by the noise power, and then we add it to the distance between the ball position and the mesh position, and we subtract the ball size from that. And then I'm using this custom function clip so that let me show you. This custom function is set to string. You can name it whatever you want. It takes a float, it outputs a float. It doesn't really matter what it outputs, because all what we actually want is this function. It's built in, and it clips, which means it makes any pixel transparent of that mesh based on the value given, and the output doesn't even matter. But you have to actually connect it throughout in order for like shader graph to actually build it into the shader, the output shader, right? Yeah, so we just put 1 so that we can multiply later by 1, which doesn't do anything. And here we are doing we are adding the threshold, and then we are doing a smooth step, and we have a smooth value here so that the the fading is smoothed out, and then we use that for our as a T for our emission color, right? So I am using just a normal color and multiplying it by a value so that it becomes brighter. And then, because you cannot have a color parameter with HDR, yeah, so if you want a brighter emission, you just multiply it by some number. And yeah, so this is gonna reduce kind of the color based on the fade. Yeah, just a color in the base color as well. So I'm also going to show this script only spawns the prefabs, and handle death is where it's attached to each of the enemies per se that are gonna die from the bullet. And I'm making sure that if there are multiple visual effects, that it's gonna get all of them, as well as the renderers. So get components in children for both of these, and get I want to create a material property so that I can change stuff on that. Excuse me. And on trigger enter is where the bullet is gonna hit. We are setting the size to starting size, which is just a parameter that you can change, and that's the starting size of the ball. So like when it hits, what's the ball size gonna start as, right? Which is immediately gonna disappear and spawn a burst. Is dead is gonna be true, and because I'm using it over there. Local position is gonna be transform.inverse transform point, and it's gonna be the position of the collider -3, and I think that's just because of the setup of my mesh. You might not need to do that. And then for each effect, I'm gonna set the ball position to be that local position of the hit, and I'm gonna send an event on hit, which is gonna do the invoke the burst effect, right, that I showed. And then for each renderer, I am going to set the ball position vector, which is a parameter, but you have to change the reference name to that, which is, I'm going to show you that. You can see ball position, you have to change the reference to be that in order for the script to be able to change that value from here. And so I changed that on the material property block, and then I set that because all of the meshes have the same material. And so if you do this way using a material property, it's gonna change this value for that instance only. It's not gonna change it on the material for all of the similar meshes. And then after that, I'm just destroying the actual bullet. And in the update, I'm checking if it's dead. Basically, if there was a hit that happened, I want to set the size of basically the ball size for both the effect and the material to this variable size, and then I am just adding to that size a parameter multiplied by time.delta time, so that that ball just keeps on growing, right? And ideally you should have also some you should call destroy after some time, right, to the actual enemy, right? So that when when the animation is like fully done, you don't see it anymore, it just destroys it. Yeah, there is a move and shoot, but that's not very important. It's just moving the enemy and spawning bullets when you shoot. Yeah, and that's it for the cubes. The where is it? The burn is relatively similar. Let's save that. I think the only differences are, you know, your fire should always go up. So I'm setting the velocity on the Y as well. And over here I am doing a different type of noise, which is or I'm sampling the same noise texture and sampling it on X and Z, you know, X and Y and Y and Z, I think. Yeah, and then combining these two so that you have kind of a, we can fake 3D noise, right? Yeah, and I'm doing the same thing in the shader. If you want more details on this, you can watch the last tutorial. I do the same thing for this noise, and yeah, rest is almost the same. I also went through this in last tutorial, which is setting the texture index, which is actually if you are giving a flip book, then I'm doing this calculation so that we set the correct index from that flip book based on the life of the particle, the lifetime. This is also covered in the last tutorial. Yeah, I'm doing a quad here because it's just a texture of fire. And yeah, that's gonna be it for this tutorial. Thank you so much for watching, and have a nice one.